So now we're going to be looking at some series and parallel resistance for some DC circuits. So what is the resistance of a, looks like this is a 100 ohm, a 2.5 kilo ohm, and a 4 kilo ohm resistor connected in series. So the series equation for resistance is just the sum. So if three of them are in series, I just sort of add them up. 100 plus 2.5 times 10 to the 3 plus 4 times 10 to the 3. And that's 6.5. That's 6.6 kilo ohm. Or 6.6 times 10 to the 3 ohm. Either is fine. If they're in parallel, we do 1 over R is equal to 1 over 100 plus 1 over 2.5K plus 1 over 4K kilo ohm, or times 10 to the 3. And so if I do this calculation, and I always just end up doing it in one shot, I do 1 over all of that. But 1 divided by 100 plus 1 divided by 2.5 E3 plus 1 divided by 4 E3, I get this is equal to 0.01065. That's 1 over R, and so then I just flip it over, do 1 over that to get 94 ohms. What are the largest and smallest resistances you can obtain by connecting these together? Well, the largest is putting them in series. That increases the resistance the most. So it's 36. R max would be in series. In series, I would just add them up like this. And that's 786 ohms. R min is 1 over 30, is putting them in parallel. 1 over 30 plus 1 over 50 plus 1 over 700. I get 20.3. Your car's 30-watt headlight and 2.4 kilowatt starter are ordinarily connected in parallel in a 12-volt system. What power would one headlight and starter consume if connected in series to a 12-volt battery? Neglect the resistance in the circuit or any change in resistance to two devices. So normally we have a 12-volt battery to two loads in parallel. One is 30 watts and the other is 2.4 kilowatts. And we know the voltage is 12 volts. So what I want to know is what the resistance of each is. This is the resistance of a headlight, resistance of the starter. So the resistance of the headlight, we know the equation based on power. We know P is equal to V squared over R. I'm going to use V because I know the voltage across the resistors, but I don't know the current. So R is equal to V squared over P, which is equal to 12 squared over 30. It's 4.8 ohms. And then R for the starter is also V squared over P, but it's 12 volts squared divided by 2.4 times 10 to the 3 watts. And that's 0.06 ohms. And so now what I'm going to do is I'm going to put them in series and then compute. Let's see, this is the 4.8, 0.06 ohms. So the total resistance is 4.86 ohms. What is the power? Yeah, so then I just do V squared over this total resistance, 12 volts squared over R. 4.86. I get 29.6 watts. So when they're in parallel, I use way more power, but this thing now draws like almost no power. Yeah. Show that. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.